So this is an exercise. So if we go back to this Colab link that I shared earlier, we have an exercise if you scroll down where I've started some of the code here. So we have a Python version and an R version, and I've created some of the code, but I've left some of it blank here. So the idea is that you're going to fill in the missing portions of this code. And the goal of the exercise is to do what we just did here. So first, to create a histogram by keeping track of the counts and sorting data elements into bins. And then once you have that histogram, to compute the mean using this weighted sum formula. And if you get the answer correctly, it should look like this. So the histogram, we already showed it, has these values 2, 4, and 1. And we have an estimated mean here, approximately 13.5. And you'll note that this is actually different from if we directly calculate the mean from the data. And that's because we're losing some information by just representing these bin values with the midpoint here. So give that a try. And I'm just going to go ahead and go through the answer here, or at least one of many possible approaches. And so I'll actually go through two ways to accomplish the histogram portion, a simple way and slightly more advanced way. So the simple way to do this is just to create conditional statements here. So we'll have 3 of them, one for each of the bins, and we'll have a for loop. And the idea is we're going to go through each data point in our data list here. So X here is our iterator, and this is going to take on the values of the data list here. And we're going to check. So inside the loop, we're going to perform this block of code. And this block is a conditional statement, or 3 conditional statements, where we first check is X between 0 and 10. And then we check is X between 10 and 20, or is it between 20 and 30? So if any of these gets activated, the first to get activated will then execute whatever code is inside the conditional. So if we're looking at this first data point, it is indeed between 0 and 10. So this would trigger the code contained in this first block here. And we'll see that what this is it's going to increment, add 1 to whatever value is stored at position 0 in our histogram list. So you see at the beginning, we've initialized the histogram list with a bunch of zeros here. So it's starting out empty, but we have 1 slot here for each of our bins. So we have 3 bins, and we know that position 0 corresponds to this range, 0 to 10. And in Python, you can use the syntax here, plus equals, and this is understood to mean that we're adding 1 to whatever value is there and updating the value immediately. Whereas in R here, we can achieve the same effect by writing it out fully here. So we take whatever the current value is, histogram, position 1, whatever value is there, add 1 to that, and then reassign it to histogram position 1. And once again, numbering from 0 in Python and numbering from 1 in case of R. So that's one way to do this. So at the end, we get this histogram list vector, and this should have our counts of how many values fell within which bin ranges. But let's say we have more bins. So if we have 10 bins, it's going to start to get a bit cumbersome to write out conditional statements for all of these cases. So what we can do is automate this step. And instead of manually specifying a particular bin index and specifying the range, what we can do is create a bin index variable, which we're going to use to smartly identify the correct position according to the data that we're looking at in this for loop, and zero in on that particular position and increment it precisely. So how do you accomplish this? How do you actually do this? So we have a formula here. And if we kind of unpack this, we can see what it's doing. So X here is our data point, right? And what we're basically asking when we want to know which bin index it's corresponding to is we want to know how many bin widths are going to fit in where that data is. So if the data is, if we're starting from 0, for example, and our data is, we're looking at this point here, 10.95, and let's say the bin width is 5. Well, we can see that 5 fits once, 5 fits twice, right? 5 plus 5 is 10. And then if we try to fit in another 5, we're going to exceed the value of our data point, 10.95 here. And that is basically the information that we want to be able to assign this point to a particular bin. So we need to know the bin width. So we compute that up here. It's just going to be the max the largest value minus the smallest value divided by however many bins you want, right? Assuming they're all equally sized. And then we'll compute this bin index formula. So we subtract the min value. So that's going to shift everything to the origin. And we'll divide then by our bin width, which we've now calculated, and then round this. So this int function here is going to turn this into an integer. And that's going to allow us to have a bin index integer that we can use then to pick out the particular bin that we want and increment that specifically. And then if you're wondering what this conditional statement is here, so this is just a conditional statement that we've added for the edge case in where if we exceed the length of our histogram, basically. So if we go over the length of the histogram, we don't want to produce an error by trying to fetch a position that doesn't exist. Instead, we're going to assign it to the number of bins minus 1, so that we put whatever comes outside of the range into the last bin. And that is the advanced way to solve this problem. So then the second problem was computing the mean. So now we have this histogram, that's useful, and then we have this formula down here, right? So if we have the histogram, that means we have these n values, one for each bin. And the next thing we need to do is compute these x values, so the values corresponding to the each bin. And you could do this, a simple way to do this would be to just, pick one of the values from the range. So if bin 1 is from 0 to 10, we could say the value is 0. And if bin 2 is 10 to 20, we could say the value is 10. But a slightly more accurate way to do this is to use the midpoint. So 0 to 10, midpoint is 5. So the value x for the first bin would be 5. And so this formula accomplishes that here. You can see why this would work. So we have I, our iterator here, is incrementing through this range, where 3 here is simply the number of bins. And so I is going to be 0, and then it's going to be 1, and then it's going to be 2 in the case of Python, or 1, 2, and 3 in the case of R. We've computed a bin width the same way we did in the previous example. And if we multiply this bin width with I, that's going to scale our count appropriately. And if we want the midpoint, we want the midpoint between increments. So I here is going to be 0. If I is going to be between 0, 1, or 2, or 3, the midpoint's always going to be 0.5 away from those. So that plus whatever minimum value we're starting from is going to give us the midpoints corresponding to each of these bins. And so that means we have all the components we need to compute this value inside the summation. So we have the n's and we have the x's, and the x's being the midpoints here, and the n's being supplied by our histogram. And now in this case, we're using the iterator I again to fetch the appropriate value from the histogram. So we're fetching the ith value here to retrieve the histogram value that corresponds to the bin that we're interested in, or the n, the height of the bin we're interested in, and computing this weighted sum by adding this computation to whatever we have there currently. And so you'll see at the beginning it's initialized to 0, but as you go through this, it's going to be added and added and added up until at the end we're going to end with this summation here. And then along the way, we also want to get the total count, right? Because that's still needed for the final calculation. We have to divide by n. So that is also taking place as we go through these bins. We're adding up the heights here, because if we add up all the heights, then that should give us the total number of data elements. And then so the final step, so the loop finishes, and we have these two values, the weighted sum and the total count. And we just need to compute this ratio here to get our value for the mean.